Okay, our goal for this lesson is to use the classical approach and form a hypothesis test on a parameter. A parameter could be a proportion or a mean or a standard deviation. You'll have to figure that out when you read the problem and determine what it is they're asking. So the problem we're going to look at here is calcium in rainwater. And if you read this, you'll see that the goal is to decide if back in 1990 when they had calcium, the calcium concentration of about 0.11 milligrams per liter, does that still hold today? So let's read this and see essentially what they're asking for. Calcium is essential to tree growth. In 1990, the concentration of calcium in precipitation in Chautauqua, New York was 0.11 milligrams per liter. A random sample of 10 precipitation dates in 2014, many years later, results in the following data. So we've got a sample here of many different readings, and if you look at the previous average or mean that they assumed, you look at this and you can see that some of them hover near the old average, like the 0.12, but some of them, like the 0.262, are quite a bit larger. So what we want to do is decide based on this sample whether or not things have changed since 1990. Okay, now they're going to go ahead and tell us that a normal probability plot suggests that the data could come from a population that is normally distributed. And they had to do that because the sample size is only 10. And unless you have a sample of 30 or greater, you're going to need to use a normal probability plot to help you decide that the data could come from a normally distributed population and that there are no outliers in the data. And they've done that for us as well with a box plot. Okay, so really our job is now to perform a hypothesis test. All right, so let's take a look at the stuff we need to know, and then we'll cross-reference over here with our classical approach methodology, and all the information we need to create the test is on this one little reference sheet. Okay, so the type of test is the clue that we need for what type of test it is really given to us right here. Does the sample evidence suggest that calcium concentrations have changed? Notice that they're not committed to whether it's gotten smaller or whether it's gotten larger. They're just saying, has it changed? Well, that means we're looking at a two-tailed test, because if it's changed, it could have either gotten larger or smaller. So right here, we know that we're talking about two-tailed. So let's just document our procedure. And then the sample size that we're working with, they're given to 10, sample size of 10. And now we need to form our null and alternative hypothesis, so we need to know which parameter is in question. Well, we're talking about a mean here, the average concentration of calcium back in 1990, they give us 0.11. So that's the status quo we're checking against, so that's parameter not. So we're going to say for our null hypothesis, H naught is that the mean is still the status quo, or what we're testing. And then H1 is that the mean is no longer 0.11. Now we also need the level of significance. It factors into all of our reference. And they gave us a 0.05, came straight out of the problem. Okay, so some things we need. So we're looking at a test statistic that's for the mean, and that requires a few things we don't yet have. We need X bar, which is the mean from the sample, and we need S, which is the standard deviation from the sample. And you can go ahead and put those 10 values into a list in your calculator, and if you run one var statistics, you're going to get an X bar, and that should turn out to be 0.1586. And then since you're reading from a sample, you're going to look up S sub X from your calculator's one bar statistic. And for S, you should get 0.0867. Okay, so now we have everything we need here to calculate T naught. So we're going to put our parts in here. For T naught is X bar minus mu naught, which is what we're testing against, the status quo or accepted mean. And we divide that by S divided by the square root of our sample size. So that's going to be 0.0867 divided by the square root of 10. All right, and if you verify that in your calculator, you should wind up with a value 1.7726. Okay, so we've got our test statistic. Now we have to make the comparison. And again, you just use this little roadmap for the reference, and this allows us to decide whether or not, based on a significance level of 0.05, we can, whether or not that suggests that there's been a change. All right, so coming over here to the comparison, let me just highlight the part here that we need. Okay, so we're talking about means, so it's two-tailed. So two-tailed and means takes us to this test. All right. Okay, so basically we're looking at if 1.7726 is less than, and what we need here is T sub alpha over 2. So and we always use n-1 degrees of freedom. So since n is 10, we're using 9 degrees of freedom. And since alpha is 0.05, 0.05 over 2 is 0.025. So we're going to go look up in table 7, we're going to look up T 0.025 using 9 degrees of freedom. And if you go look that up with 9 degrees of freedom, you should come up with the value 2.262. All right, so now we have this part here, the T alpha over 2. We have to use it twice. First comparison is if our test statistic 1.7726 is less than negative T alpha over 2, so negative 2.262. You can see that that's false because one's positive and one's negative. So, but we also have to say or test statistic is greater than regular T alpha over 2 without the negative in front of it. But neither case succeeds. These both fail. Okay, so notice that we only reject H naught if one of these are true. Since neither are true, we do not reject H naught. Okay, that gives us all the information we need to issue the statement. So basically what we're going to pass on to our colleagues, or however you like to think of this, we would say there is not sufficient evidence at the alpha equals 0.05 level of significance to suggest or conclude that calcium concentrations have changed. Since 1990. Okay, so there's the formal procedure to figure out whether or not a parameter is still valid based on past information, and we do that using hypothesis testing.